All right, let's take a quick trip back in time. The year is 2011. This is before the cloud was everything, a time when if you needed some serious computing power, you often had to get your hands dirty and build it yourself. And this is the story of a few tech pioneers who came together online to solve a really big problem. How do you build a supercomputer and, actually get it to work?
So what exactly were they trying to build? Something called a GPU cluster. Now, in simple terms, it's just a bunch of computers that team up, pooling the power of their graphics cards. See, those GPUs aren't just for making video games look amazing. They're absolute wizards at crunching huge amounts of data all at once. So by linking a bunch of them together, you're basically creating your own specialized supercomputer, one that can chew through problems that would completely overwhelm a regular machine.
But here's the kicker. Back then, you couldn't just hop on YouTube and find a 10-minute tutorial for this stuff. There was no step-by-step guide. It was pretty much uncharted territory. So the big question, the one everyone was wrestling with, was how do you physically assemble this thing? And then, the really tricky part, how do you get all the different software pieces to actually talk to each other?
That problem was a huge roadblock. But that's where our story really gets going. One person decided to step up and draw the first map, to create that first blueprint. We're going to call him the pioneer.
This post pops up from John Forrest over at UC Berkeley. He shared his super detailed notes on the build. But honestly, the most important part of the whole post wasn't the technical stuff. It was the last thing he wrote. I'd welcome corrections. That wasn't a boast. It was an open invitation to a collaboration. And that simple invitation was what got the ball rolling.
And if you really want to get into that 2011 mindset, just take a look at the hardware they were working with. We're talking a 6-core processor for the main computer, 4-core processors in the others. I mean, your smartphone probably has more power than that today. But back then, this was the raw material you needed to build an absolute beast.
John's approach to the build was really methodical. He broke it down into 4 main steps. First, you've got your basic prep work. But step 2, that's where the real genius is. He actually modified the installer's code to make it hands-free. Why does that matter? Because it was the key that let him automate the entire software installation across all 7 of his other computers, his nodes, all at once. That was a huge insight for making this whole thing scalable. So John's blueprint was a success. The cluster was built, the software was installed, but the story doesn't stop there. His guide ended on this massive cliffhanger. He'd solved the hardware part of the puzzle, but one really critical piece was still missing.
And this is just a fantastic example of the whole collaborative spirit of the thing. John comes right out and says, hey, I haven't figured out the best way to configure SGE to handle the GPU cards. Then he just throws the problem out to the entire community. I'd welcome any suggestions. It's like he built the car, but now he needed help figuring out the rules of the road.
So what is this SGE thing he's talking about? Well, SGE stands for Sun Grid Engine, and it's basically a job scheduler. The absolute best way to think about it is like an air traffic controller for a supercomputer. Its whole job is to look at all the tasks that people want to run and then efficiently assign them to the right computer, or in this case, the right GPU, without causing any pileups. Without it, the cluster is just a bunch of powerful hardware with no organization.
Now, John's call for help didn't just disappear into the internet void. Not at all. The community jumped in immediately, and this fascinating debate sparked to life, with different people proposing their own ideas for how to solve it.
2 main ideas kind of bubbled to the top. On one side, you had a guy named Dave Krause, who came up with this really elegant theory. His idea was to configure the GPUs in a special, exclusive mode, which would let the scheduler see them as a resource it could count and hand out. It made sense, but it was just a theory. On the other side was Dong Do, who shared a super practical method he was already using in the real world. His approach was way more direct. Just create a special, separate line, or queue, just for GPU jobs and force all those tasks to go there.
And the collaboration just kept going. Another member, Hongsheng Cao, chimed in, but not with a direct solution. Instead, he shared a resource. He pointed the group to a similar project at the University of North Carolina, basically saying, hey, maybe we can learn from how these guys solved it. It's such a perfect example of how open communities work, building on shared knowledge.
So, the theory was interesting, the outside links were super helpful, but in the end, it was Dong and Do's proven, practical, it just works method that delivered the big breakthrough. This was the final piece of the puzzle that John had been looking for.
And the solution itself was just beautifully straightforward. Dong Do laid it out in 5 clear steps. He created a special rule and a dedicated queue just for GPU tasks, and then told the system which computers belonged in that queue. Now, step 4 was really the key. Putting all the GPUs into an exclusive mode to make sure 2 jobs didn't try to use the same one at the same time. And finally, he provided simple instructions for everyone to use it. It was a complete, elegant solution from start to finish.
And how did he know it worked? He wrapped up his post with this simple, confident, and honestly, perfect confirmation. Works pretty well for me that way. In the world of complex systems and endless debugging, hearing that is as good as gold. The problem was officially solved.
You know, this entire story, the problem, the collaboration, the solution, it all played out in just 2 days on a public email forum back in 2011. It's a fascinating snapshot of a moment in time, but it really leaves us with a bigger question for today. In our world of automated cloud platforms and AI tools that can write code for us, is this kind of messy, creative human collaboration, this back and forth, is that still the secret ingredient to real innovation? What do you think?